Welcome to Big Southern Butte in the Snake River Plain of southern Idaho. This is the most prominent topographic feature in the Snake River Plain, rising some 2,500 feet above the valley floor. Just an incredible topographic feature here that just dominates this portion of southern Idaho. Thanks for joining me. I'm Geology Professor Shawn Willsey out here having an adventure at Big Southern Butte. A place I've been to before, but it's been a number of years, so I thought it'd be fun to come back out here again, do a video for you to show you its incredible geology, talk about how it formed and such. So let's go ahead and check this out together. So what's striking about Big Southern Butte is it's such a contrast from the other volcanoes we see here in southern Idaho. Some of the volcanoes we see here in the Snake River Plain might be more like what we see here in the middle ground, this small, steep-sided spatter cone, just rising maybe about 40, 50 feet above the valley floor. Very small volcano. Of course, it's dominated by basalt in terms of rock type. A more common type of volcano we see here in the Snake River Plain lies just over here to my east at Cedar Butte. So this is a volcano that is a shield volcano. This is formed from basaltic lava flows that pour out. They're very low viscosity. They just spread out across the landscape. And these are the more typical types of volcanoes you see here. But what you often don't see, and what makes Big Southern Butte quite special, is something this massive, something thousands of feet tall, steep-sided, which is a very different type of topographic feature we see here in the Snake River Plain. So before we head up onto the mountain, let's start with a quick overview of exactly how this volcano formed.
So Big Southern Butte began as a rhyolitic intrusion beneath the stacks of basalt that exist in the Snake River Plain. So here in the diagram you can see the red rhyolitic magma rising, starting to pool up at the base of this thick stack of basaltic lavas here in the Snake River Plain. As that progressed over time, that rhyolitic magma began to push up the basaltic lava flows above it, doming them upwards. And as that rhyolitic magma eventually made its way to the surface and broke out as rhyolitic lava at the surface, these thicker and more dense basalt blocks actually sank in the rhyolite. The basaltic magma and basaltic rocks are more dense than the rhyolitic material, and so they actually formed slabs that sank down into the rhyolite itself. However, on the north side, that side stayed attached to the basaltic lava flows out on the Snake River Plain, and what we have on the north side of Big Southern Butte is a thick stack of basaltic lavas that are steeply tilted down towards the north that make up the north flank of Big Southern Butte. So Big Southern Butte is a lava dome, or what's sometimes called a volcanic dome.
Okay, so we're over here on the north side of Big Southern Butte. This is the access road that gets you up to the top. Quite a rugged road, four-wheel drive definitely recommended. We're here by the BLM sign for Big Southern Butte. But what's striking here is as we look at this canyon we're about to drive up, you can start to see some of the different rock types here. If you look up to the ridge line on the west, you can see how the rocks are very white and light colored. Those are the rhyolites that formed when Big Southern Butte was created about 300,000 years ago. And as we look over here to the east side of the canyon, a little hard to tell with the sun there, but the rocks are definitely a lot darker in color. So these are the basalts. This is the big slab, if you will, of basalt that was pushed up and is tilted and pretty much confined to this north side. So let's hop in the truck and head up the road and go check out some more of the fantastic exposures and features here at Big Southern Butte. All right, so we're high here on Big Southern Butte, just near the summit. We'll go up there in a bit here. You can see the road that heads up to the summit region, but just some really fantastic views from this lofty spot looking down basically 2,000 feet or more into the Snake River Plain. View there to the north or northeast. It's a little hazy out, but we can see some of the mountains in the distance, the Lost River Range, the Lemhi Range. Just down here, we can see a knob of some of that dark basalt, that slab of basalt that's been uplifted and is tilted to the north here on the north side of Big Southern Butte. But the main thing we're going to check out here as we kind of work our way back down the road to a really fantastic road cut that really, I think, nicely illustrates some of the eruptive properties from Big Southern Butte, some of the different rock types we find here. Real quick off this side, we are looking down to the south across the Snake River Plain, and you can see some of the outcrops of rhyolite here, these lighter colored rocks that make up most of Big Southern Butte. But definitely when you're on the north side, you do see a little bit more of the basalt. So here is the road we're going to check out, and we're going to look at some of the different rock types here. So mainly, again, rhyolite, but we're going to look at this in a little bit more detail. And again, this was just thick, pasty lava that just welled up and oozed out of the ground. In places, the rhyolite cooled quite quickly, and where it's cooled quite quickly, we get obsidian. So we get a little different rock type here. Obsidian is, of course, volcanic glass, but this forms from these felsic or silica-rich magmas. And if they cool quick enough that crystals aren't able to form, elements aren't able to combine to form mineral crystals, you get obsidian. But if there's time for the crystals and the elements to move around and link up to make minerals, then you get this more sugary, light gray rhyolite, what we see here. So you can see some crude bedding in this stuff. Let's see if we can get up this slope here. Let's find a nice face here. Yes, you can see some of the overall bedded, well, it's not bedded, but it's layered, and this is actually most likely what we call flow foliation. So it's this thick, pasty lava just kind of oozes out, and it cools and crystallizes, and it oozes out and crystallizes and cools. You get this banding in it. You can see it's a little bit crumbly here, pretty easy to break apart, at least in this location. And there are spots where we can see some of the the crystals in here, mainly quartz and potassium feldspar, making up most of the crystals we see here in the rhyolite. Let's go down a bit further down the road, because it's a pretty lengthy road cut, and there's a lot of surprises to be had. So here we have rhyolite from lava oozing out, this thick, pasty lava coming out of the ground. And that's probably what makes up this type of exposure, is what you mainly see here on Big Southern Butte, at least the places I've looked at it. But as we work our way down the road, there you can see the banding is slightly tilted to the west or to your left there. But then there's this interesting zone here where we get a little different color, more of a red, orange, brown color with the rhyolite. And let's go take a look at this stuff here. The rhyolite lava in places can be very broken up, or what we call brecciated, and we're seeing a bit of that here. This is just a bunch of particles of this rhyolite that have been broken up. You can see how large some of these are here. This big block here is nearly a meter or so, 3 feet in diameter. But they've all been cemented together, and these are quite hard here. This is actually a pretty hard unit, much more cohesively glued together. So I think my interpretation here would be that these more red deposits have been oxidized. There's iron oxidation that's gone on here, and a likely cause of the oxidation, along with the better cemented nature of this unit, would be what we call hydrothermal alteration. So there's been hot water and gases that have moved through these broken particles, oxidized what little bit of iron was in there, but also provided mineral material that could really cohesively cement and glue all these particles together, because you definitely see a difference in how cohesive and well cemented the unit is here versus in other places here in on the road cut, looking at the outcrop. So pretty interesting spot here with these red hydrothermally altered breccias. We can see those continue down for a little ways, but then it changes color. So let's head down, ski down the hill, and let's head back down to the road cut and walk down a little bit further. One of the great activities that takes place here at Big Southern Butte is, and the road is super gnarly, but for those that dare, this is apparently a good spot to go hang gliding. So there's actually folks that come up here just past the trees with their hang gliders and launch off this site. Again, on a clear day, and today's not the clearest day, but on a super clear day, you can see the Tetons. The views are incredible, pretty much a 360 view in any direction from this lofty spot here in the Snake River Plain. So now as we work our way down the road and look at the exposures here, a little different, still highly brecciated, but lacking the reddish color we saw back up the road. So that red zone in there is probably just a place where the hot gases and maybe groundwater, if this was underwater, there was a little bit more movement of that material through the rocks that allowed it to be a little bit better oxidized and cemented. But you can see how huge some of these blocks are. This block here in front of us is maybe 2.5 meters across, 7 to 8 feet, something like that. Really large material. And then here we're starting to see, again, a little bit more of the layering going on here. So there's some crude layering going on. You can see there's smaller particles at the base of this exposure, and then much larger blocks of rhyolite a little further up. But the main thing I want to take you to is this west end of the outcrop. Still seeing little specks of obsidian in the road here and there, contrasting nicely with this white or light gray, kind of sugary looking rhyolite. This section of the road's a lot of slope wash. Can't tell as much what's going on here because it's not a good exposure. But then we get down to this spot, and there's a really fantastic exposure that provides a clue as to how these lava domes or volcanic domes can behave at times. And so if we come in here and look here, we see we have a bedded deposit. You can see some organization to the material here. Unlike the rhyolite up to here, which was all in cohesive rock, these are individual particles or clasts. And if we look at some of these particles up close, like pull out some of these blocks here, these are incredibly lightweight. So this is, super lightweight. And if we look at it closely, it has a lot of tiny holes in it. So these are chunks of pumice blocks that are, very poorly glued together and kind of just compacted. But this suggests that we had an explosive phase. So not only was this volcanic eruption oozing out this thick, pasty lava, but at times that lava was more gas rich and it was exploding the material up into the air, creating these blocks of pumice. That material then was raining down around the vent and on the landscape and accumulating and being deposited. And so this is a material, this is mostly, fist size and smaller for the most part, but this is what we would call lapilli, these size particles, or pyroclastic particles, or tephra, and this would be sort of the lapilli size range of material. A few that are a little bit bigger, but mainly in that size range there. So really fantastic outcrop, showing us the explosive nature of these rhyolite lava domes at times. It's not just always effusive extrusions of this thick, pasty lava, but at times with a little bit more gas-rich component to it, it can erupt much more explosively and throw out, in this case, we've got blocks that are maybe, soccer ball size particles that are being thrown out onto the landscape, airborne. So really nice material here. And we still see in places in here, there's other things. There's a contrast with this other, there's a contact here with this lighter colored unit. Definitely the one below looks pyroclastic in nature. The one above, not sure I'm seeing quite as much pumice in that. So it's possible that's another pyroclastic unit sitting right above, but it might be, oh, actually there is some pumice particles in there. So I think it's another explosive unit, a little different color, different event most likely, and a few maybe different classes. It looks like it has a little more diversity in class types, and that's why it's a little bit darker overall. And there is even specks in here of, I can get that one out. Let's see. There's even little chunks of, hopefully it can show that okay. Little pieces of obsidian that are showing up in the deposit as well. Sorry if that's not getting focused really well. So we do see a little piece of obsidian being thrown out with all the rest of this material as well. Pretty cool. Well, let's head up towards the summit area and see what we can see from up there, and we'll sign off from up on the summit area. But this has been a really cool treat here to see some of the deposits from the eruption and formation of Big Southern Butte. Well, here we are at the summit of Big Southern Butte, and just wouldn't be a real trip up Big Southern Butte without coming to the summit and just looking at this fantastic 360 panoramic view from up here. Again, it's a little hazy. I've been up here with a little better air quality days, but there's still quite a bit you can see here. So I guess first thing I'll point out is the road cut that we just visited. So you can see that hillside there with the cut in it just above the trees. So that's our view to the northwest, looking at the end of the Lost River Range there in the distance. As we kind of come over here to the northwest side, the most prominent thing out there in the distance are the, oops, there we go, sorry. Prominent thing out there in the distance are the dark lava fields of Craters of the Moon. So the Craters of the Moon monument are those dark areas out there in the distance, that black lava field you can see there. So that forms a nice little viewpoint there. As we come over here to the south side of the butte, which is pretty spectacular because it's more or less straight down off the butte here, down to the flats, but looking at some of the younger volcanoes. Remember, Big Southern Butte's 300,000 years old, so all these other shield volcanoes, basaltic vents down there are actually younger than that. So we're looking to the south across the Snake River Plain, and then as we come over here more towards the east side, we can see a couple of things here. We can see the this great shield volcano down here. This is Cedar Butte. So that's one of the shield volcanoes there. And then just past the towers here, off in the distance, you can hopefully make out those two prominent buttes. So those are similar to Big Southern Butte, another set of lava domes. That's East Butte and then Middle Butte there a little bit closer. So the three of these somewhat line up on an east-west axis. So these are three lava domes, rhyolitic lava domes that have risen up through the Snake River Plain and form very different types of geologic features, these big steep-sided domes. So pretty fantastic. A trip up Big Southern Butte is always a highlight for me. Well, thanks again for joining me on this little adventure up Big Southern Butte, the most prominent topographic feature in the Snake River Plain of southern Idaho, ties to the Yellowstone hotspot, fantastic volcanic features, just really cool geology up here. Thanks for your support of the channel. Make sure you like the video, and we'll see you next time. Take care.